Well, to the clinicians, I would say this. There are hundreds of randomized controlled trials treating depression with psychotherapy. There are hundreds of randomized controlled trials treating depression with exercise. There are hundreds of randomized controlled trials treating depression with nutritional supplements. So to believe that SSRIs are the primary thing at your disposal is crazy.
If you're on an SSRI or other antidepressant, I want you to think back to when it all started. In the doctor's office. You know the day. You probably discussed options, made some decisions, and hopefully your doctor spent time going over what to expect over the next weeks and months of taking the medication. You know, the changes you'd expect in your brain, but they also discussed the changes to expect in your body, your very physiology. And my guest today is on a mission to change that, to make sure they do and think about it differently. Dr. Chris Masterjohn is a biochemist and nutrition scientist who holds a PhD in nutritional sciences from the University of Connecticut and previously performed postdoctoral work in the comparative biosciences department at the University of Illinois. He then transitioned from academia into independent research, consulting, and education, and he runs a Substack called Harnessing the Power of Nutrients and has published in-depth material on mitochondrial health, nutrient optimization, and lately, the broader systemic effects of SSRI, selective serotonin reuptake inhibitors commonly used for depression. His mission is to help individuals optimize their metabolism at the cellular level, especially the mitochondria, for performance, longevity, and for brain health and mental resilience. And he's really encouraging us to ask some big questions like, are mental health medications being viewed through too narrow of a lens? And simply put, are SSRIs kind of messing with our metabolism more than we realize? He's also the host of the Mastering Nutrition podcast and a former vegan turned carnivore. So really interesting experience. So please welcome Dr. Chris Masterjohn to Metabolic Mind. Well, Chris Masterjohn, thank you so much for joining me today at Metabolic Mind. It's a pleasure to be speaking with you.
Thank you for having me. Pleasure to be here.
Yeah, you've written so much and produced so much content about, brain health, about mitochondrial health, about nutrient optimization, like this whole world of interconnected sort of circles, I guess you could say. And I'm interested in talking all about that. But before we get into the details, give us your background. Like, how'd you get interested in this whole field and what excites you about it?
Well, how I got there is really just from personal experience. For me, it was really seeing the profound influence of nutrition on mental health. I had been vegan, and while I was a vegan, I had anxiety problems that I had had since I was a teenager get dramatically worse to the point where I would say I was borderline psychotic. I'll skip through most of it, but there was a period of time where it was very difficult for me to even eat any food because I was so paranoid about what had been done with it. And it's just suddenly hit me that I had completely changed. I was like a completely new person to the extent that I had forgotten why. And so what happened in between that time? What happened was I had encountered the work of Weston Price, who was an early dental researcher turned nutritional anthropologist who had traveled all around the world trying to find the causes and consequences of tooth decay. And his big take-home point of his magnum opus, to summarize decades of research, was that animal foods, and especially animal foods rich in nutrient density, which he highlighted as organ meats, dairy products, seafood, especially shellfish, insects, and small animals like frogs. And notably, insects and small animals like frogs are generally consumed nose to tail, and so therefore are good sources of organ meats, or organs anyway. And I looked at this and I read this book because I was trying to fix my teeth. Like, as a totally separate problem, while I was vegan, my teeth fell apart. And so I'm trying to fix my teeth. I have no expectations it's going to do anything for my mind, but in trying to fix my teeth by eating nutrient-dense animal foods, I accidentally cured myself of, not only had I swung away from that pendulum, but I was in a state of extreme mental resilience. And I had completely forgotten about all the mental problems that I had before that. So that's what motivated me to study nutrition science in greater detail, both to understand what I had gone through and also to be able to help other people and pay it forward. And so that's kind of what led me down the career of researching metabolism, but with a special interest in how to improve mental and brain health in doing so.
Yeah, it's always so interesting when someone has that deep personal experience that leads to their academic and research careers and their scientific careers. I mean, it's got to start from somewhere, and why not start from a place of personal passion? But one of the dangers with that, though, is we can sort of be biased or blinded by our own experience. So, I mean, as a scientist, and this is a little bit different direction than I thought we'd go in the beginning, but I'm curious, like as a scientist, how do you make sure you are not, overly influenced by your own personal experience?
Well, I think the only way to do that is to maintain openness to new data. I would say most people tolerate plant-based diets better than I do. I do think that it's a minority to thrive well on plant-based diets, and I say that in part because there's not a lot of research on it, but there's a couple surveys, and in general, ex-vegans outnumber current vegans by 3 to 1. So I think that in general, people who swing too far in the plant-based direction, the majority of them are swinging back. So I do think that the median person is not well suited to the diet that I was on, but a lot of people go on diets like I was on and don't have anywhere near the extent of those problems. So I do think I'm an outlier in terms of the severity that I had. So I think knowing that I'm an outlier, and I guess, there were definitely times where maybe I was more of an evangelist for animal-based diets than I was an evangelist for individualized diets, which I think I'm more of now. And I always suspected that I had some kind of genetic defect in synthesizing something that was not in plants, is present in small amounts in all animal foods, and is present in large amounts in organ meats. That would be the simplest way to explain how I could have such a dramatic response to that. And I have spent a little bit of time analyzing my whole genome, and there is some truth to that, but it turns out to be a little bit more nuanced than that. I think most people's genetics are, I think a lot of people have like 2 to 7-ish really big things going on in their genetics that interact. And then, there's quite a number of common polymorphisms that sometimes are all oriented in one direction that can lead to an outlier as well.
And that's what's so challenging about genetic tests, because sometimes the polymorphic changes are in opposite directions. One says, you're going to be higher in something. One says you're going to be lower in something. So how do you interpret that? But when they're all pointing the same direction, that's when you might get a potential signal. So I think that's an important thing just to mention with genetics, is they're not always black and white. To tell you, like you said, you have a clear genetic defect in something that's an organ meats is not so black and white, but you have to sort of piece it together. I think that's interesting.
My own perspective is that that's almost always the case, and it has to be mathematically that if you have a large number of common changes, on average, they have to produce the average, right? So like the average effect of all the polymorphisms in the population is the average person. So in general, everyone's walking around with a small handful of very rare mutations with a high likelihood of being super impactful to them. So I think that's I think that's the kind of the area of genetics that no one is really looking at.
Yeah. Well, so we kicked off this discussion, I guess, right into the details of the genetics and maybe some of the nutrients. So if somebody wants to optimize their brain health and to know what they need to do to optimize their brain health, do they all need to get a full nutrient profile, a full genetic profile? Like, is that step one, or do you have other steps that you recommend and maybe that's not necessary for everybody?
Well, I mean, step one could be anything, and it's always going to be where your weakest link is that you're going to get the most progress from. And so, a lot of people's mental health is just getting, if they can, find something that gets them out of a victim mindset or something like that, that might be the game changer for them. But, if we isolate the conversation to nutrition, then I don't think step one is to do a bunch of testing, but but everyone should do comprehensive testing. It doesn't make any sense not to. And it does wind up, costing some money. But in my experience, the biggest way to waste money is to not get testing, because you're trying to save money, because what it just leads to, years of suboptimal decisions that make you, supplement with things that you didn't need, lose productivity in work that you didn't have to lose. And it's just a total illusion that you're saving money by not getting the highest quality information as fast as you can. But, with that said, like, it doesn't make any sense to do lab testing if your diet is terrible, right? So it's like, why would you eat a riboflavin deficient diet and then like go get your riboflavin tested and find out it's low? It's like, did you need that test? No. So I think the order of operations is, first, clean up your diet, like eat what you think is do what is the right thing first, right? Like most
Do
people
people
are.
know what the right thing is? I mean,
Well,
I guess people
that's not my
know.
point. That's not my point. You
Okay.
don't know what you don't know, but I'm
Yeah.
saying execute on what you think you know, right? And so for example, like, most people eat way too much food out. Most people eat way too much ultra processed food. Most people don't eat enough nutrient dense foods, however you define that. There's all sorts of controversies about whether it should be more plant based or more animal based, higher protein, lower protein, high fat, low carb, low fat, high carb, whatever. So there's plenty to play around with, but I'm saying, like, step one is, for most people, is to just, get off your butt and do what you actually think to be correct. And then I think the best step two is to get an app like Chronometer and track your diet, at least for, if you eat the same thing all the time, maybe 3 days. If your diet is super variable, try to track enough that it captures a representative snapshot, and then just test. You think these things are a good diet, but if on paper you're 80% away from micronutrient targets, then you were wrong about something. And so you can then use that as a tool to improve your diet. But then, I do think that it also depends on motivation, right? So I recently came up with an optimization framework where I created basically a flow chart that says, are you happy with the results you have? And if the answer is yes, it's, if it ain't broke, don't fix it. And if the answer is no, it's, are you in an emergency? And if the answer is yes, it's seek medical help. And if the answer is no, then it's like, okay, you want something more than what you have, but it's not an emergency. Now it's time to do one of two things. You can just take things that are low. The first thing you would do is take low hanging fruit of what, the buzz on the street is like, I have headaches, and oftentimes people get better when they have more salt or they have more water or whatever. Just take the low hanging fruit and try that. And if that's not working, now you really have to optimize. And if you're going to you don't have to stay an optimizer forever, but you have to enter a cycle of optimization enough to achieve the things that you're trying to achieve. And then you can reassess whether you're happy with your results. If on paper your diet looks great, but there's something about your health that you want to improve, then testing your nutrient status is the right next step. Because you could, like we were talking about before, maybe you have genetic polymorphisms that influence the absorption of a nutrient, or maybe you have genetic mutations that impact the ability of the nutrient to do its job. And your riboflavin looks great on paper, but you actually need 6 milligrams, not the 1.3 that the official recommendations say should be fine for you. And it's going to be really hard to get 6 from food, but you could do it if you knew that your health was dependent upon it. And so that testing might show, hey, your riboflavin looks great on paper, but your riboflavin levels are really in the gutter. And I think that at this point, we kind of know what to do with that. Whereas I think actually uncovering like what is the specific genetic mutation that determines that, I think is a much harder puzzle that requires a lot more expertise.
But
Yeah.
I like the way you sort of started this by saying first is clean up the diet and know what you're doing with the diet before you get in all that test. And I think that's important because as a physician, I've seen so many people who say, "Oh no, I eat healthy. I eat a, insert label here, vegetarian diet, vegan diet, Mediterranean diet, whatever it is. So therefore I eat healthy." But really they probably have no idea what they're actually eating and what their nutrient breakdown is and what their macro breakdown is and what their calories are, right? So I like how you started by saying quantify it. Go to Chronometer, go to or some other service and actually input what you're doing so you have some idea. Then after that, if you're not getting the results you want, that's when you can get nutrient testing. I sort of like that sort of flow. That seems to make a lot of sense. But I think it is important that so many people think they're eating well when they really don't know what they're eating. And that applies to low carb and keto and carnivore or whatever, right? Like it can apply across the whole spectrum. So we don't want to give a health halo to certain ways of eating just because it fits a certain definition. Do you agree with that?
Well, I guess your first point, I would say just more broadly, most people think things that are just generally wrong about things that they think, and just tracking something will clear things up really fast, so like most people also don't think they waste much time, but if they start tracking their time, they're going to find otherwise, right? So I do think that's true with your diet. If you start tracking your diet, you're probably going to eat better than you usually do just because you're tracking it. Like I actually, I noticed this a long time ago that when I was tracking my diet to see something about it, I started eating closer to the better conforming to the ideal that I wanted to see in the data because I was paying more attention to it. But I guess your other point is you have an idea of what's healthy, but it might not be healthy for you, or it might not be as healthy as you think it is. The nutrient tracking thing is the reason that's important is because it's a lot of people have preconceived ideas about what a healthy diet is, but they don't have preconceived ideas about how much riboflavin they should be getting. And so, you're exiting all the baggage that you have about your ideas of what's healthy when you start tracking the micronutrients, because it's an objective marker that you didn't actually have a preconceived idea about. And so it's just, your if you don't think about, that's not true for me, but it's true for most people. And so if you're not someone who nerds out on micronutrients, now you're confronted with a wall of truth when you see your micronutrient report.
So when it comes to mental health and mental health optimization, what are the top 3 micronutrients that you think most people are deficient in and should pay attention to?
I don't agree with the concept. The reason that I don't like these ideas of taking the average and saying like, what are the top 3 that people need to be concerned about, is that, as soon as you take a population who's paleo, suddenly their nutrients of concern are totally different than the population. As soon as vitamin D is a nutrient of concern in the general population, but not in the people who are listening to podcasts on health because they're all taking 5,000 IU. You go to talk to vegans, their nutrients are totally different. So my opinion is that there is nothing in your brain that is made without all of the nutrients, right? Like you take one thing that you have off and it's going to be the thing that impacts your brain health most. So I think it makes way more sense to say like, each person, whatever your limiting bottleneck is, whatever you're running low in is going to impact your brain. And if you've got a problem in your brain, you should be looking at the stuff that you might be low in. And yeah, there are, and then the other thing is, if I'm going to pick something like omega-3 fatty acids or something like that, I'm just going to be recapitulating what is already oversold on brain health, right? So like, even your doctor should know that, you got someone on cognitive decline, they should probably be getting their omega-3s. And so I think you wind up oversimplifying it in a way that's just not the person that's listening to it it's not what they need to hear is that everyone needs to go out and take magnesium, vitamin D, and fish oil. What they need is a lesson on individualizing their diet in ways that don't necessarily require them to have an expertise in their genetics. And I think that comes down to the top three things that I said before are do what you know is right, see if you still need some help, analyze your diet to see what you are low in. And if everything looks great on paper, it's time to do some testing to find out what's the limiting bottleneck for you.
Yeah. I like that because most people aren't going to have access to the genetic testing or the nutrient testing, and at least not right away. So it's good to have some solutions that don't depend on that. So transitioning for a second here, though, I want to get to something you wrote about SSRIs. So specifically Prozac, I think it was, that you wrote about as a performance-enhancing drug, which I thought was...
that was Prozac. Yeah.
Yeah, which I thought was really interesting and kind of attention getting. Like, wait a second, Prozac isn't a performance enhancing drug. What's he talking about? So I want to give you a minute to just sort of explain what you meant there, and then we can sort of dig into sort of the mechanisms of brain performance and mitochondria and neurotransmitters and how it all fits together. So how is Prozac a performance enhancing drug?
Well, that was kind of a teaser for the series, which was looking at a mouse study where they showed that Prozac helps boost strength and muscle mass, but exercise is a superior antidepressant. And, I think that just highlights that SSRIs are, totally misunderstood. And by the way, human randomized controlled trials also show that exercise is more effective than SSRIs. And, there will be people that argue, well, good luck trying to get a severely depressed person to exercise, whereas I can get them to take an SSRI. But anyway, my point is, in that mouse study, that's not a one-off fluke. Exercise is a more effective antidepressant than SSRIs in network meta-analyses of hundreds of randomized controlled trials. It's a fact. So anyway, what we don't have is a lot of data showing the performance enhancing drug aspect of SSRIs, but there is an anecdote. There is a runner, I forgot their name, but who also swore by Prozac as a performance enhancing drug. But what it goes to show you is that whatever you think SSRIs are doing is wrong.
Right. And it also probably goes to saying whatever you think the mechanism of depression is probably wrong, right? Because we got into the simplistic thinking that, SSRIs increase serotonin and can, in some people, help depression. Therefore, depression is a serotonin deficiency, right? End of story. It's very clean, tight in a bow, and we got it. But it's clearly more detailed than that. And I don't even, I don't mean to say that doctors are saying it's that clean, but that's sort of the way practice is. But instead, it sounds like you like to focus on, as we talk a lot about here at Metabolic Mind, on the brain energy, the brain's ability to transform energy and the mitochondrial function. So how do you first of all, do you think that's the underlying sort of mechanism or connection for brain health and mental illness? Does it get down to the mitochondria and brain energy?
Yes, I think depression is a matter of brain energy metabolism. I think serotonin is not a mood-altering neurotransmitter. I think that's a horrible way to see it, and I think it's primarily involved in modulating energy metabolism. I don't think serotonin is unrelated to depression, but I think the mainstream idea on what its relation is totally wrong. That's based on the mainstream understanding of serotonin being totally wrong. And that in turn is just based entirely off the way that SSRIs have perverted the science of serotonin and completely gotten it off its original track and taken it out of the realm of biological science and into the realm of marketing materials. The SSRI driven half century of seeing serotonin as a mood booster is an anomaly that is finally going to take a seat, and the actual serotonin science is going to come back, and we're at that moment now. So here's the proper way to situate serotonin in the context of what we know about it. The primary driver of serotonin in the brain is light. So if you look at animals and you just put them in many different conditions and then cut out their brains and see how much serotonin is in there, we wake up in the morning, the light comes into our eyes, and that's the trigger to increase serotonin in the brain. Why is that the case? Well, Waking up is a period of time where your mitochondrial energy metabolism has to rise to the event of a higher metabolic oxygen demand to suit the demands of wakefulness. So when you go to sleep, your body does two things. One is it decreases energy production because that allows the mitochondria to rest, but it also decreases metabolic expenditure a lot more than that. So that way your mitochondria can rest, but they're still producing an excess of ATP versus the demand, so you can replenish your energy stores when you wake up. When you wake up, the first thing that happens is your metabolic demand goes through the roof. Because imagine, even laying down relative to sleeping is metabolically expensive. Now you get up and you go downstairs and you try to make coffee and you try to think about what you have to do, your metabolic demand goes totally through the roof. What happens is the exposure to light increases the production of serotonin in the brain. The serotonin then helps the mitochondria adjust their gene expression to increase their metabolic output. And in the meantime, while that transition is taking place, serotonin goes into the mitochondria, it gets converted into melatonin, and then the melatonin actually helps the mitochondria make energy without enough oxygen. So this is not a textbook thing. This is like cutting edge science, but there are numerous studies mechanistically that show that the presence of serotonin and melatonin in the mitochondria act in a way that will allow the mitochondria to keep producing ATP even when the oxygen levels are lower. We don't know exactly what it's doing. I have two hypotheses. One is that melatonin's engaging in redox reactions that help electron flow. Another is that it's engaging in light shifting reactions. There's no support for either of my hypotheses, but the general principle that serotonin, by being converted to melatonin in the mitochondria, helps the mitochondria make energy in the absence of oxygen is true.
But I think the key take home to that, though, is just the importance of early morning light. I mean, we've heard a lot about that, but people maybe haven't talked as much about the mechanism. So you're saying that early morning sunlight into your eyes is a direct stimulator of mitochondrial energy production, basically. And that's why we need it to get going and improve overall health and mental health for the day. Is that accurate?
Yeah. There's one randomized controlled trial that showed chronotherapeutic approach, which primarily consisted of 30 minutes of bright light in the morning every day. There was also some sleep hygiene recommendations. That caused twice the remission rate for depression as exercise did. And we know that exercise is more effective than SSRIs. It's only one clinical trial, but the effect size is massive, right? So tying it into my idea of how this all works, I'm willing to place money on morning sunlight is one of the most effective things that you can do for depression. The reason is waking up is a form of contextual but repeatable hypoxia. And it's not that you are being strangled. It's not that your oxygen supply goes down. It's that your demand goes up and your body has to go through a transition. So there's a period of time where it's not only about oxygen getting to the mitochondria, it's also about mitochondrial gene expression. The general use of oxygen in the mitochondria is deficient relative to the metabolic demand.
So it's not so simple as just give someone supplemental oxygen and they'll be fine, because they still have to be able to process that oxygen on a cellular level.
That's right. And so what that's telling you is that this sleep-wake cycle being interpreted by our biology as about oxygen flux and hypoxia adjustments is, what I'm saying is the cells agree with me, and it's massive. Like the inability to make that regularity. And the reason the circadian rhythm is so important is because when it comes to gene expression, you're actually producing more stuff every morning in the cell. Like the cell, if you're involved in manufacturing and you know what your orders are going to be next month, you're going to have a much better off time meeting them than if you have no idea what your orders are going to be next month, right? So it's that type of thing. Like if the cell knows that that every morning at 7:30 is when you wake up and need to meet the demands of the new day, then the cell's prepared to do that and is much better able to meet those demands.
So when it comes to sleep hygiene and people say go to bed the same time every night, wake up the same time every day, is that, you think, part of the mechanism behind why that works?
Oh, for sure. I mean, so first of all, your ability to regulate that is driven by the differential between the morning sunlight and the nighttime light, right? So if you get rid of artificial lights at night, if you wear blue blocking glasses, and you have 30 minutes of bright sunshine in the morning, those two cues, if you do them at the regular time, are going to be the most effective way to ingrain, they call it entrainment, to entrain your circadian rhythm, meaning to make it, very regular. I mean, you don't really have to do anything to make it regular. You just have to not get in the way, right? So if you're staying out till 4 a.m. on Friday night and you're sleeping in till 2 p.m. on Saturday morning because you're a party animal, now you're getting in the way of those cues, right? So if you just get out of the way and you get regular sunshine in the morning, and when the sun goes down, you don't blast yourself in the eyes with bright lights. If you just practice those two things, the regularity will fall into place automatically. And I'm not saying no one can ever go to a party, but you just have to realize that there's some cost to it. You have to try to not regularly interfere with your body's rhythm. And so when you wake up in the morning, the light stimulates serotonin synthesis in the brain. And then on a cellular level, the serotonin goes into the cell, which SSRIs block because they block serotonin transport. And the problem with SSRIs is, yes, they can help boost synaptic serotonin, but they do that at the expense of a number of things. One is they don't allow serotonin to go into the mitochondria. Another is they go into the cell themselves and act on receptors that help mitochondria, but they're supposed to be driven cyclically and rhythmically, not 24/7. So you achieve a steady state with these. Now the mitochondria get addicted to the SSRI. People go off SSRIs and they get new onset mitochondrial dysfunction. And then the third problem is that once SSRIs actually get to the mitochondria, now they're mitochondrial toxins. So you have this mix. It's, no wonder there's so much controversy over these drugs, because they're doing a mix of good and bad things. And in general, they're playing with mitochondrial fire.
Yeah, so I think we need to start to wrap up here for time, but this has been a really interesting, detailed understanding of serotonin and the mechanics and all the cellular level. But if you were going to sum up where, mental health research and clinical care should focus over the next, 5-10 years, whatever it is, how would you sum that up in a few sentences? Like, what should be the focus of where we're going?
Well, to the clinicians, I would say this. There are hundreds of randomized controlled trials treating depression with psychotherapy. There are hundreds of randomized controlled trials treating depression with exercise. There are hundreds of randomized controlled trials treating depression with nutritional supplements. So, just to believe that SSRIs are the primary thing at your disposal is crazy. Familiarize yourself with the literature. Second, I would say, if you're a general practitioner, you should refer someone to if you believe in SSRIs, you should refer people to a psychiatrist to do that. General practitioner, you should not consider yourself capable of treating someone with a psychiatric drug. That's
going to be controversial. Wow.
I don't care. The psychiatrist shouldn't be giving out SSRIs either, except in in extreme circumstances. And I think a general practitioner that prescribes SSRIs like candy is not an ethically good practitioner, and so I think they should change that. I think it's absolutely crazy that general practitioners consider themselves qualified to prescribe SSRIs. And I say that because I know for a fact they've never read the meta-analyses on psychotherapy, nutritional supplements, and exercise. Otherwise, they wouldn't be giving SSRIs out like candy.
Right. So in their defense, though, I would say it's less on the physician and probably more on the guidelines and sort of the APA and the organizations and sort of their stepwise approach, which frequently involves, it gives some lip service to nutrition and lifestyle, but then really focuses on the medication. And so if physicians are following those guidelines, they're doing what they're sort of educated to do.
My message to those clinicians is that you should put an emphasis on keeping up with the literature as much as you put an emphasis on reading standard of care, number one. Number two, you should read the articles written by the founders of evidence-based medicine who said that a clinician who is ruled over by the evidence-based is tyrannized. Read David Sackett's article, Evidence-Based Medicine, What It Is and What It Isn't, in BMJ. It's like 4 pages long. David Sackett was the founder of evidence-based medicine, and he says in there that one thing that evidence-based medicine isn't is a top-down tool to control what practitioners do in their clinical practice, which he said, and I quote, would be tyranny. So if you think that evidence-based medicine means practicing standard of care without knowing the literature, I want to tell you to read David Sackett's article. Read my SSRI series if you really want to get into it. You will think 7 times, not twice, about prescribing an SSRI before you prescribe nutrition, psychotherapy, and exercise. I'll say that.
All right. That's a good way to wrap it up, I think. So where can people find your, serotonin series, and where can they follow you for more information?
Yep. chrismasterjohnphd.substack.com. You can also go to chrismasterjohnphd.com. You can also type Chris Masterjohn into your favorite search engine. And then, of course, my new project that I'm most excited about is I'm founder and scientific director of Mitome, so mito.me, for my mitochondrial testing, which definitely is the next step after getting your nutrients right in terms of optimizing your mitochondrial energy production.
Well, very, very thought-provoking. So I appreciate you taking the time and sharing all your information with us. So thank you.
Thank you so much.
Thank you for watching. If you want to see more, check out these recommended videos. Also, if you haven't already, don't forget to subscribe to our channel to stay up to date with our content and help us expand the movement. And if you want to sign up for our newsletter, access our resources, read the latest research, or check out the Think Smart framework, click here to visit our website. See you on the next video.